Okay, so I put circles and ellipses on the same in the same section because they're almost the same thing. I mean, I want to connect how all of these shapes are related. So these are also sort of related to a parabola like we just did, but circles and ellipses are very much the same thing. So here's the general idea of a circle. Here's the general equation, the standard equation of a circle. It's written like this. Okay, so some things to notice. Oops, this should be K. So in this case, the vertex is at HK. Okay, so it's still whatever the zero of this one is, it's still whatever the zero of this one is. So these two are the shifts of the center of the circle. Oh, that's not equal to 1, that should say r squared. Okay, so this is the radius. It's the square. So when you take the square root of that, that's how big the radius will be. So that's how big the circle will be. And then this is the center of that circle. Okay, so one of the things that we have to be able to do, just like in the last one, and it's a really important section in all of the conics, is you have to be good at completing the square. Because when you complete the square, that's how you see where the vertex is, which is why that's been somewhat of a recurring topic throughout the whole course. Completing the square. So let's take a look at number 2 down here where it's all stretched out. So here are a couple things that I want you to notice. Notice that the x term is squared. That means it's going to cross the x-axis 2 times. And notice that the y term is also squared. It's going to cross the y-axis 2 times. That's what makes it a circle. So you'll cross the x-axis in 2 spots and the y-axis in 2 spots. So to get all 4 of those points, it makes a circle. So anytime the x is squared and the y is squared, it's a circle. It's a circular shape. Now, it might be shifted. The center might not be at 0, 0, so it actually might be down here, and it might not touch either of the vertices. There might not be zeros on either one. But the idea of the squared is if it's centered, it's going to cross the x 2 times, and it's going to cross the y 2 times, which makes it a circle. That's just how you can identify that this is going to be a circle. All of this other stuff is shifts for the vertex. The -6, the 4, those are going to have something to do with where the center is, the vertex is. I shouldn't say vertex here, I should say the center. It's the center of the circle. The -6 and the 4 are going to decide where the center of the circle is, and then the 9 is going to decide something about how big the circle is. The 9 is going to become some kind of the radius, and the -6 and the 4 are going to become some kind of the center. Now, it's not going to end up probably being 9, and it's not going to end up being -6 and 4. You'll see what happens here in just a second. Okay. So to get it in this form, we have to take this form and complete the square on the x's, so it looks like this, and complete the square on the y's, so it looks like this. And then all the leftovers are going to be turned into the radius. Okay, so step number 1, let's rewrite this. I'm going to rewrite this with all of the x's together. So I'm going to say x squared minus 6x, like that. I'm going to put the 2 x terms together and then leave a space. And then I'm going to put the y's, y squared plus 4y. And then I'm going to take the 9 and put it on the other side, so it all equals -9. Notice I left a space after the x and I left a space after the y, because that's where I'm going to complete the square. I need half of the 6, which makes it -3. And then that's what we'll square in there. -3 squared is a +9. Okay, if I add 9 on this side, I have to add 9 on this side to keep it balanced. Okay, then I'm going to have the y term, so half of 4 is 2, and then I'm going to complete the square. 2 squared means I'm going to need a 4 there. If I add 4 on this side, I add 4 on this side. Okay, this -3 is what it factors to now, so this becomes x minus 3 all squared. See how I got it into that form? Plus, and then this becomes y plus 2 all squared. And then over here, the -9 and 9 is 0 plus 4, so it all equals 4. Okay, this term right there is the r squared term. R squared equals 4, so when I square root both sides, I have a radius of 2. Okay, so they want us to identify the center and the radius. Okay, that's the radius. The radius equals 2. Okay, and here's the center. The center is what makes these zeros. The x part is 3 and the y part is -2. So the center is at 3, -2. And then sketch the graph. Okay, 3, -2. 1, 2, 3, 1, 2. So right there's the center. Now radius 2 means it's going over 2, and then over 2, and then up 2, and then down 2, and then we can sketch the circle through those. Okay, that's the process. So on this one over here, number 3 over here, we got to complete the square. Once you complete the square, then the rest of it is all just, do you know where the answers are? So first, complete the square. So I'm going to reorganize the x's. I got x squared plus 4x, leave a space, and then I've got y squared minus 6y, and then I'm going to move the 2 to the other side, so it all equals 2. Have the 4. Complete the square. 2 squared is plus 4. That means I got to add 4 on that side. Have the -6 to -3. -3 squared, -3 times -3 is positive 9. If I add 9 on this side, add 9 on that side. Okay, here's the factored version. X plus 2 all squared. Here's the factored version. Y minus 3 all squared. 2 plus 4 is 6 plus 9 is 15. Okay, that spot is r squared. So r squared equals 15. So the radius is the square root of 15. That's how you should answer it. That would be the exact value. So the radius, square root of 15. Here's the center. The center right here is at -2, positive 3. So that's how we'll answer that. The center is at -2, positive 3. And now we want to sketch that graph. So -2, positive 3 is right there. So there's the center. Now the square root of 15, you can go to your calculator, but if I just do a little bit of a thinking bubble here, the square root of 16 is 4. Well, 15 is just below that, so the square root of 15's got to be somewhere around 3.9. I don't really even have to go to my calculator. It's going to be just under 4. So when I do this radius, it'll be just under 4. So from the center, 1, 2, 3, 4, just under 4. 1, 2, 3, 4, just under 4. 1, 2, 3, 4, just under 4, and 1, 2, 3, 4, just under 4. Now, I don't have it on here. I meant for us to identify those points. So those are called the vertices. So let's add that in there. I have it in the other equation, other questions, the vertices and the covertices. So I will ask you to do that, to also have the vertices. The vertices are these points. So let's add it on this one over here. Now notice, so we'll just call these the vertices. Okay, notice when I went sideways, see this dot right here is there. This one's down 2 and this one's down 2. So for both of those, it's -2. The y part is -2. And then this one was at over 2. Oops, it was over 5 down 2. So that one was at 5, 2. And this one right there is at 1, -2. There's 2 of them. But what I'm saying is the -2's were the same. And then on the other one, that one up there is 3, 0. And then the other one is 3, -4. But notice the x's are the same. So let's add those in as part of the answer. So over here, the vertices, okay, here's how you can write them. To get these two, the sideways ones, I want to add, that's going to make the x's different. See that it started at -2 and then I added almost 4. I added like 3.9. So you write it like this: -2 add the square root of 15, whatever that is. I don't actually need the value. It's -2 plus, that's the exact value. And then going the other way, see that's almost 2. It's 1.9-ish. Then going the other way, I want to go from -2 and subtract the square root of 15. So that's both vertices, and then they both have an up spot of 3. See, that's 2 points. That's like this. It's like saying them both. See, over here I could have said, okay, I could have gotten both of those as 3 plus or minus the radius of 2. See, 3 plus 2 is the 5, and 3 minus 2 is the 1, and then made the y part -2. See, that's both answers right there. And then for the other one, the other vertice, so now the top and the bottom both have an x of -2, but then it's the y value, the 3, that goes up root 15 to get that one. So say I went up 3 plus another root 15, or I could go up 3 down root 15. So this is how you answer all 4 points if you have a square root in there. Okay, so those are circles. You just complete the square, and then that gives you the center and the radius. Now, an ellipse. Think about a circle. Here's a circle. You go over and over some kind of a number, and then you go up and up the same number, which makes it round. All an ellipse is you still go over and over, but then the up and down number is different. It's a circle, but it's been stretched. It's been pulled. Maybe it's been pulled up. Or you have the up and down numbers are the same, but the sideways numbers have been stretched. So sometimes it's stretched that way. So an ellipse is very much like a circle. It has a center. It's very much like a circle. But an ellipse is rotating around 2 focus points. So when we're talking about an ellipse, these 2 focus points, if I put a point on the ellipse anywhere, that distance plus that distance is always what's called the major axis. The major axis is the longest distance. Okay, so it doesn't matter where you put it. I could put it right there. If you go from the point to the focus plus the point to the other focus, that always adds up to the major axis. If I put it right here, if I go to the focus plus the other focus, that adds up to the major axis. Okay, so we have some labels here. If I have an ellipse like this is called the major axis. This is called the minor axis. So we have it's kind of like a long radius and a short radius. Then, so we have a center. That would be the center, just like in a circle. But then this is focus 1, and this is focus 2. And those 2 focus points, just like in the parabola, it made radio waves bounce to the focus. These 2 focus points, always any point on the circle, when you add the 2 distances to the focus point, it always adds up to the major axis. Okay, here's the format for these. It looks just like a circle. It's x minus h all squared plus y minus k all squared. But now the small axis and the long axis are different numbers. See, up here, this axis and this axis were the same. So in a circle, it's always equal to just whatever that radius is. But on an ellipse, we're going to always force it to equal 1. So that's a big deal there. It's not equal to r squared, it's equal to 1. And we put the radiuses underneath here since they're different. So we call this one a squared and this one b squared. Now, whichever one of these is bigger is which way it goes. If the x radius is bigger, that means it's stretched on the x-axis. If the y radius is bigger, that means it's been stretched on the y-axis like that. Now, I'll show you how to deal with these in just a second. Okay. Let's take a look at this one. So it's already in this form, so it's already equal to 1, so that has to be true. Check. Okay, good. Well, once that's the case, then right here is the center. Okay, so there's our center. We can just label that. The center is at +1, -3. So the center is going to be at 1, 1, 1, 1, 2, 3. So there's our center. Okay, this is the x radius. Notice it's squared, so a squared equals 36, so the a is equal to 6. That means from the center, the x radius is over 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 units from the center. So that means the major axis is now 12. And same thing here. B squared is equal to 9, so the y value is up and down 3. The y radius is up and down 3. 1, 2, 3. 1, 2, 3. Okay, so we can sketch that. So we'll just sketch it around there. Okay, those are the vertices. So let's get these two sideways ones first, the vertices. Okay, notice the sideways ones are all down 3. So the y part is down 3. Let's not do it yet. So the y part's down 3. The x part is starting at 1, and then it went up 3 and down 3. So I'm just going to call it 1 plus or minus 3. See, that's like saying 4 1, 2, not 3, sorry. That one was 6. So, okay, going sideways, we went sideways 6. So we started at 1, and then we went plus 6. That's this one. Then we started at 1, and we went minus 6. So you can call that 1 plus or minus 6. See, one of them is 7 over 7 down 3, and then the other one is 1 minus 6. That's negative 5 down 3. That's these two. Okay, the other two, these two went up and down 3, so the y-axis is, so they're both at 1, the center point 1, and then they started at negative 3, but they went plus and minus 3. See, negative 3 plus 3 is 0, that's this one. And then negative 3 minus 3, that's negative 6, that's this one. Okay, so there are the vertices. Okay, we got the center, we got the vertices are the long ones, the co-vertices are the short ones. And then we need the focus point. Okay, so let me show you how to get the focus point. We need the focus point, first of all, is always on the long axis, on the major axis. So the focus points are going to be just inside the major axis. This is going to be a focus point. I'm just going to call it focus 1 and focus 2. Okay, the way you find them, we need some more formula up here. So here's the focus formula. Okay, it's a squared minus b squared equals c squared. It's almost the Pythagorean theorem. Now, when I say a, I mean a in this context as the bigger one, the longer one. So this has to always stay positive, and the b is going to be the smaller one. Now, it doesn't matter. See, b does not necessarily have to be under the y for this. This just has to stay positive. It's the big one minus the small one equals the c one. And the c then is the focus distance. Okay, let's see what that means. Okay, so here's the a squared. See, that's already the a squared number. It's 36. And here's the b squared number. It's 9. So I'm going to go a squared minus b squared equals c squared. So that's 36 minus 9. 36 minus 9 is 27. So c is equal to the square root of 27. Now that has a 9 in it. So the square root of 27 is 9 times 3. And the 9 can come out. So the c number is 3 square roots of 3. Okay, that's this distance right here. 3 times the square root of 3 is about, well, let's see, square root of 27, that's about 5.2. That's approximately 5.2. It's 5.2 units from the center. 1, 2, 3, 4, 5.2. It's right in here somewhere. Okay, so that's that focus point. That one is starting at the 1. It went 3 roots of 3 more, and then it's down 3. And this one started at the 1, and it went left 3 roots 3, and then down 3. So the way that I usually write them, just like the vertex, I'll just say F for focus. It was 1 plus and minus 3 roots 3, down 3. Now, what that has done, you don't have to do this, but this is just for a teaching point. I can put a dot anywhere on the ellipse. That distance plus that distance is 12, because 12 is the major axis. That line plus that line I know equals 12. That's what ellipses do. And likewise, I can really put the dot anywhere. I can put the dot way over, I could even put it right there. That distance plus that distance is 12, right to there. So that little line plus that long line is the major axis. Okay, let's do another one. Okay, so here's the center, -2, -1. So there's my center, -2, -1. Got it. -2, -1, right there's the center. Okay, this is the a squared number, and this is the b squared number. So a is 3 and b is 6. So the x, notice this one is under the x. The x has got a radius of 3. 1, 2, 3 sideways, 1, 2, 3 sideways. The y has a radius of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this one is up and down. That means the focus points are going to be there and there. Focus 1 and focus 2 are going to be like that. So here's the center. The vertice points, starting from this center at -2 sideways, I went plus and minus 3. And then the other vertice point, starting at -1, I went up and down 6. So there's the 4 vertice points. Now I need the focus points. Okay, I get the focus by doing the big squared minus the small squared equals c squared. Okay, the bigger number was the 36. So we got 36 minus 9 equals c squared, which again gives me 27. So here c is 3 square roots of 3, just like it was before. So, but now the focus points are going up and down from the center. So both of these focus points have an x of -2, but then starting at -1, I went up and down 3 roots of 3. And there are the solutions we're looking for. And the graph. Okay, well these were in the nice clean format. This is the easy format. Let's turn the page. Most of the time ellipses are not in their format. They're in the flattened out format like this. Well, we've got to complete the square and get it in that nice easy format. Notice that the x is squared. It's going to cross the x 2 times. Notice the y is squared. It's going to cross the y 2 times. But now notice they both have multiplier, they have different numbers in front of them. That means they're stretched differently. So up here when we had a circle, the x had a 1 in front of it and the y had a 1 in front of it, the x squared and the y squared. That means they were both stretched to the exact same amount, which meant the x-axis and the x radius and the y radius were the same. Now they're going to be different. One of them is stretched more. It looks like the x is stretched more, but that may or may not be the case. We have to put it in the other format first. But this is giving me a hint. Okay, it's going to cross the x-axis twice and it's going to cross the y-axis twice, but they have a different leading number, so it's going to cross them both twice, but now one side's going to be stretched more than the other. So this gives us the indication it's an ellipse. All this other stuff becomes the radius and the center shifts. So we do the same thing. We have to complete the square to get it in the other format. So let's do it the same way. 16x squared plus 192x. Put the x's together, leave a space. Then y squared minus 4y, leave a space, equals 0. Okay, I'm going to complete this square first because it's easier. Okay, half of -4 is -2. Square that in. -2 times -2 is plus 4. So if I add 4 on this side, I have to add 4 on this side. It's this one over here that I need to be careful of. This leading term, if you remember from a long time ago, has to be 1. So I can't start out with that being a 16. So I have to this always has to start in order to complete the square, is 1x squared. So out of these two, just this part, I'm going to factor a 16 out of there so that the x squared can be cleaned off. So there's dividing out of 16 here, 192 divide out of 16. Is 12. So taking a 16 out of that is a 12x, and then I still have the whole to complete the square in. So I have the 12 to a 6, complete the square. 6 times 6 is 36. So I added 36 on this side, I gotta add 36 on this side. But it's not really 36 because of this 16 that we already took out. It's 36 times 16. So 36 times 16 is 576. This side I added 576. So this side also gets added 576. Okay, now we have the thing completed. It's 16x plus 6 all squared. This was the perfect square part. Plus basically a 1, and then y minus 2 all squared. There's the perfect square part. Equals 580. Okay, let's compare what we have to the form. The form for these is always equal to 1 when it's an ellipse. When it's a circle, it's equal to the radius. But when it's an ellipse, it's equal to 1. Okay, that means I have to force this 580 to become a 1. Well, that's easy to do. I'm just going to divide everything by 580. Okay, so one of the things that I can do here is treat this. So what I have is, looks like this radius is 580. That's going to equal 1. So let's take a look at what we have. We have 16. Basically, I can think of that as a fraction. I have 16 580ths x plus 6 all squared. It's basically like that. Plus y minus 2 all squared over 580 equals 1. So I have it equal to 1 like I need. The problem here is, notice the form, there's no multiplier on the center point shift. It's all in the denominator. I have to get this fraction so that it's all in the denominator. So really I don't want this 580 here. So really that's like the number 16 580ths. If I have the number 16 580ths in a fraction, and I want to move it all downstairs. Remember when we did exponents, if you move everything to the other side, you get a -1 power. That would move it all down. So really, let me do it a different way. I want this part to be a 1, so I'm going to multiply by 580/16 so that those can reduce to a 1. Because the formula needs a 1 up here with the center, and it's got this 16 580ths. Well, if I multiply by 580/16 on the top, I have to multiply by 580/16 on the bottom, and see what happened? By getting this 16 580ths and forcing a 1 on the top, it basically flipped it over. Okay, so that's what's going to happen here. I've got to get this 16 to the denominator. Well, it's going to make the denominator that same fraction only flipped over. So what we end up with here is x plus 6 all squared over 580/16 plus y minus 2 all squared over 580 equals 1. Now we have it in the correct format. That is the format of a circle, of an ellipse. It equals 1, and all of the radius is in the denominator. So there's the center, -6 2. So I've got a center of -6 2. I think I'll go ahead and plot that, -6 2. So here's my center. Okay, here's the radius for this one is the square root of 580. So see, that's equal to b squared there. So I need the square root of 580. Okay, I'm going to be 580. I'm going to take the square root of 580 and see about what that is. It's right at 24. Okay, I'm not going to worry about, I'm not going to bother figuring out what the perfect squares that are in there. I'm sure there are some. I'm just going to leave it the square root of 580. So the vertex going sideways, see it's on the y, so this is the up and down vertex. It's going to come off of the 2. It's -6, and then I started at 2, and I'm going to go up 580 and down 580. That's both of them right there. So it's going to be up that basically 24. 1, 2, 3, 4, 5, 6. So it's way up here, and I'm not going to do it all, and way down here. It's 24 up and 24 down, basically. And then this one, the a squared number, is that. Now, when I square root this, that's going to be a little bit easier. So that means a is going to be the square root of 580. And then the square root of 16 is 4. So I can just put that one under 4. The square root of 580, and then the square root of 16 was 4. So that at least turned out nice. So this is this one cut and divided by 4. So if I do the square root of 580 and divide that by 4, it's going sideways about 6. So the other vertex is -6 plus or minus the square root of 580 over 4 over 2. Or up 2, I mean. So starting at this -6, it's going this number. So it's going to about 6. 1, 2, 3, 4, 5, 6 in just a little bit. And 1, 2, 3, 4, 5, 6. Okay, so there's my shape. Okay, here's where the focus will be. The focus is always on the inside. So my focus is going to be right there. I'm just guessing right now. I'm just putting the dots in there, and I'll write down exactly what they are. So the focuses are up and down. Okay, so here's my focus formula. The focus is big squared minus small squared. These are the radiuses, equals the focus number. So the big one was right here, square root of 580. So I've got the root of 580 minus the small one was the root of 580 over 4. Okay, I think I'm going to get that. Let's see, can my calculator do that? So this is basically one of them, and this is 1/4 of them. I have one of these 580s minus 1/4 of these 580s. So that will be 3/4 of the root 580. Okay, I'm going to get basically a decimal. So 3/4, so 0.75 of the square root of 580. It's right at 18. Okay, so c squared is right around 18, and I want to square root both of those. So I'll take that to the square root power of 1/2. So it's right around 4.2-ish. Okay, I think let's go ahead and go decimals with some of that. So let's just call it 4.2. So c is approximately 4.2. I probably will let you do that here also. So the focus points now are up and down. So they're both -6. They're going left 6. And then starting at 2, I'm going up and down 4.2-ish. So 2 plus 4.2, it'll be about 6. 1, 2, 3, 4, 5, 6. So really the focus was way down here, not way up there. It was way down here. And the other focus down 6, right on there somewhere. Okay, these are the numbers that we need. So let's take a look at number 8. We got to complete the square. Looks like this one might be a little bit easier. Okay, completing the square. That's all there is for x's, so there's nothing to do with that. The y, don't even need to leave any space. There's nothing going on there. The y's are 49y squared minus 98y. Leave a space to complete the square. Okay, out of all of this, I'm going to factor out that 49, so that leaves it y squared minus 2y. cut this one in half, square it in. -1 squared is +1. If I add 1 on this side, I got to add 1 on this side, but it's not really 1. It's connected to that 49. So I added 49 to this side, so I'll add 49 to that side. So our actual equation so far is x squared. That just means it has no shift. That's like x plus 0 squared plus 49. Here's the completed part. Y minus 1 all squared equals 49. Okay, the rule is it has to equal 1. So I'm going to divide by 49, divide by 49, divide by 49. So really now I've got x squared over 49. Those 49s cancel out. So I have y minus 1 squared over 1 equals 1. Here's the center, 0, 1. Okay, the A number here is 7. That's the X radius. The X radius is 7. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. So those two vertices were 0 plus and minus 7 up 1. Here, taking this b squared is 1, that equals b squared, so b is still 1. When b squared is equal to 1, square root is still 1, so the y is up and down 1. So the y is only going up 1 and down 1 from there. So for those, starting at 0, then on the y we had 1 plus and minus 1. Now, when they're really wide like this, the focus points are pretty far in, but when they're narrow, the focus points are going to be pretty far out there. They're usually pretty far out towards the vertices. Okay, so to get the focus points. The focus points are the big one, so this 49 right here. So the focus point will be 49, that's the a squared number, minus the b squared number is equal to c squared, so that's 48 equals c squared. So c is the square root of 48. Okay, over here it was just easier to deal with it as a decimal. Let's deal with this one just as an exact one, square root of 48. So our focus point is from the center, left and right, 48. So 0 plus and minus the root of 48 up 1. So that's that focus point and that focus point, and we have those. That's about 7, so you can see we went over 7 already, and this is like 6.9, so see the focus points are really close to the edge. Okay, if you got it, you can go ahead and do the homework, but if you want to watch the next two, so the next two are exactly the same. I just wasn't sure if some people want another couple of examples. Some people are ready to go, so I'll let you don't have to do 9 and 10 if you don't want to, but I will. Okay, so complete the square. I need x squared minus 4x. Leave a space. 25y squared plus 100y. Move the 79 to the other side. Complete the square. Cut it in half. -2 squared is 4. Add 4 here, add 4 here. Okay, here we got to factor out the 25 before we can complete the square. So 100 divided by 25 is 4. Cut it in half is 2. 2 squared is 4. That's a fake 4 because it's connected to the 25, so really that's 100. Add 100 here, add 100 here. Okay, now let's get it in the nice form. There's the perfect square, x minus 2 all squared. Plus 25, there's the perfect square, y plus 2 all squared. And over here, what's 104 minus 79? 25. Oh, how convenient. Okay, it has to equal 1, so I'm going to divide by 25, divide by 25, divide by 25. Those go away. Those reduce out. So we have x minus 2 all squared over 25 plus y plus 2 all squared over 1 equals 1. Here's the center, 2, -2. 2, negative 2. The x, plus and minus 5. So the vertex from the 2, we're going to go plus and minus 5. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. From the y, we're going to go plus and minus 1. So the other vertex, starting at negative 2, we're going up and down 1. So up 1, down 1. There's the picture. Okay, the focus points will be there and there. Okay, let's see what they are. The big one squared minus the small one squared equals c squared. So we end up with c squared equals the root of 24. Well, c equals the root of 24. Okay, so they're going sideways. So the focus points are starting at the 2, and then they're going to the right and to the left root of 24, down 2. That's that point and that point, and we have the whole thing. So we can complete the square, get all the other information off of that. Okay, number 10. I'll do number 10. I'm going to put the x's together. There's 4x squared. That's it. I'm going to put the y's together. Y squared plus 10y. I'm going to put the 21 on the other side, leaving a hole so I can complete the square on the 10. Okay, drop down half as much. Square it in. 5 squared is plus 25. If I add 25 here, got to add 25 there. Okay, here I have a 4x squared. Here's the completed square on the y's. Y plus 5 all squared. And it equals 4. Okay, we got to make it equal to 1. So I'm going to go ahead and force it equal to 1. So now those are 1. Those are 1. So I have x squared over 1 plus y plus 5 all squared over 4 equals 1. Here's my center, 0 makes that a 0, negative 5 makes that a 0, so our center's at 0, negative 5. You can plot that. Okay, the x radius is 1. Sideways 1, sideways 1. It's the square root of this number. Well, the square root of 1 is still 1. So our vertex is 0 plus or minus 1. And here it's 2. Square root of 4 is 2. So that means we're going up 2 and down 2. So our vertex for those are starting at negative 5, go up and down 2. And there's our shape. The focus is going to be on the major axis. So the focus will be up and down this time. So to get the focus points, it's the big minus the small equals c squared. So c is the square root of 3. So our focus points, they're starting at 0, and then it started down 5, but up and down square root of 3 from there. And there is everything. Okay, give those a try.